As the inverse operation for the exponential, a logarithm can help us solve exponential equations. We begin with an equation like this that clearly does not have a whole number answer. There's no power of 4 that gets us directly to 15. We suspect that the answer will be close to 2 because 4 squared is 16, but we're not positive exactly where that answer is. This is where a logarithm comes in and can be helpful because we understand the logarithm as the inverse. So what we're going to use here is we're going to take the logarithm of both sides of this equation. So we're going to take the natural log of 4 to the x, and we're going to take the natural log of 15. We have a power rule for logarithms that says that this exponent, as the exponent of the argument of the logarithm, that exponent can be brought to the front of the logarithmic expression. And this left-hand side can be rewritten as x natural log of 4. The right-hand side we didn't touch, natural log of 15. Now we have the x that we're looking to solve for out of the power, and we divide both sides by the natural log of 4, and we get that x is equal to the natural log of 15 equals over the natural log of 4. Typing that into a calculator very carefully, we get that x is about 1.95, which jives with our thinking from before. You did not have to use the natural logarithm. You could have used log base 10. That does not change the solving pattern at all. The x still comes down to the front. And we divide. And, whoops, that's supposed to be a 4. And we divide and we get log base 10 of 15 over log base 10 of 4. Typing that into a calculator very carefully, we still get that 1.95 answer. Both of these expressions should have looked a little bit familiar. If we walk back to the beginning of this equation can be rewritten as log base 4 of 15 is equal to x. This is not a log that we have a calculator button for. But if we use the change of base property on this expression right here, we would get one of those two expressions. So there is a synergy between our understanding of exponentials, our ability to rewrite them as logarithms, our ability to solve them by taking the logarithm of both sides, and the change of base formula, where all of those pieces all fit together. Now, it's not going to be always that easy. It only ended up looking this nice, neat, and orderly because the x was the only thing in that exponent. We're going to look now at an example where that x is not by itself. The answer is not going to look as clean, and that's okay, but we're still going to follow that same process of taking the logarithm of both sides. Before we take the logarithm of both sides and have to engage the product rule for logarithms, we're going to start by dividing by 7. We're going to isolate that logarithm, that exponential as best as we can. We know there's no whole number power that gets us from e to 9, so we take the natural log of both sides. The natural log is the best choice here as we have a base e expression. So we take the natural log of both sides. The power rule for logarithms allows us to bring that 2x down to the front, leaving the natural log of 9 by itself. Right here is where it gets especially interesting because this just has a value of 1. What's the power of e that gives you e? Well, that's just 1. Multiplying that by the 2x, we're left here. Dividing both sides by 2, we get that x is equal to the natural log of 9 over 2. This is what we would call the exact answer. If we wanted an approximation, the calculator could help with that. We get about 1.099 or 1 in 99 thousandths. We can always sub that back in to test to make sure we get approximately 63. This moment that you round this number right here, your back substitution is not going to be exact, which means your answer is not going to be exactly 63 when you're done with the evaluation. We're looking for close to 63. We're not looking for perfectly 63. That's a hard distinction to make because we're saying we're solving this equation, but I'm giving an answer that's not perfect. If you were able to carefully type this into the calculator as the power instead, the exact answer as opposed to the approximate answer, then you would have had a lot more success actually getting that number 63 and having that come out perfectly.